All right, in this video we're going to look at another application of polynomials here, and this is with maximizing profit. So let's look at this example. So again, if you don't have my notes, you don't have to worry about writing all this down. You might want to just write down some of the key information. So I'll underline that as we get through it, as I read through this. So it says, Sweet Co. Beverage Company sells cans of soda and machines. It finds that sales average 26,000 cans per month. So let's highlight that. Okay, so sales average 26,000 cans per month when the cans sell for 50 cents each. Okay, so that's all important right there. For each 5-cent increase in the price, the sales per month drop by 1,000 cans. So I guess you do have a lot to write down. So if you want to pause the video and get that in your notes before moving on, that would be a very good idea. All right, so what are we trying to do here? So it says determine a function, so we're going to call this function r of x, that models the total revenue realized by Sweet Company, where x is the number of 5-cent increases in the price of a can. All right, well, let's think about how we determine revenue. So revenue refers how much money we're going to make. And so we would figure that out by the price times the sales. So the price per can times how many cans we're going to sell. So that's how we would figure out the revenue. Okay, so let's think about that even further. So the price, we're going to refer to this as the price after a certain number of increases. Here's what I mean by that. If you notice, x is the number of 5-cent increases. So that's really important. So if you don't have that in your notes, write that down. X represents the number of 5-cent increases. So currently it's 50 cents. And so if we have one 5-cent increase, then we would be charging 55 cents. If we had two 5-cent increases, we'd be charging 60 cents, and so on. So we're going to have an equation, we're going to have an expression there that's going to represent the price after x increases. Then we're going to have another expression that's going to represent the sales after x increases. So if you notice, I'm putting these x's in parentheses or in quotation marks there because I don't want you to think that that's a multiplication symbol. It is not. That x there is referring to the x variable. So we would have the sales after a certain amount of x increases. So how do we represent these as expressions then? So let's start with the price after x increases. So remember, we're starting with 50 cents per can. So that's our current price of the cans of soda. And we could have any number of increases, but for the increases are referring to 5-cent increases. So let's just stop here for a second and make sure you understand why we have this. So if we would have one, so if x again represents the number of 5-cent increases, so if we had one 5-cent increase, we would have 50 cents plus 5 cents, and that would be 55 cents. If I put 2 in there for x, that would represent two 5-cent increases, and 0.05 times 2 would be 10 cents. And so we would the cost per can would be 60 cents, and so on. So now let's look at how we can determine an expression for the sales after x increases. Now, currently, they sell about 26,000 cans per month. But what's going to happen is they're going to lose, because obviously, as it gets more expensive, people are going to decide it's not worth it. But at the same time, you're charging more, so even if less people are buying the cans of soda, since you're charging more, it's going to make up for that difference. And so we're going to lose 1,000 customers or 1,000 cans for each 5-cent increase. Okay, so it says right there in the last paragraph up here, it says for each 5-cent increase in the price, the sales drop by 1,000 cans. So so if we had one 5-cent increase, we're going to drop our sales by 1,000 cans. And so we would only sell 25,000 cans. If we had two 5-cent increases, yes, we're going to be charging more for the can, but we're going to lose about 2,000 cans per month. So now we would be down to 24,000 cans per month on average that we would sell, and so on. All right, so the next thing I want to do is I want to multiply these together because we want to get a function to represent this in standard form. So what I'm going to do is I'm going to use my box method. I want to get some rather large numbers, and so that's why my box is kind of wide here. And so we would have 50 cents plus 0.05x on one side, and 26,000 minus 1,000x on the other side. And so when we multiply these together, 26,000 times 50 cents, or 26,000 times 0.5 would be 13,000. 26,000 times 0.05 would be 1,300. So that would be 1,300x. Negative 1,000 times 0.5 would be negative 500. So this would be negative 500x. And negative 1,000 times 0.05 would be negative 50x squared. So I'm going to put this in standard form. So I'm going to refer to this as my revenue function. So we're going to say r of x equals, I'll put this in standard form, so negative 50x squared. And then 1,300 minus 500x, so those are like terms, those combine to be 800, so it'll be 8 plus 800x, and then we'd have plus 13,000. So that's the first part of this problem. So that is what we would call our revenue function. Let's look at part B. All right, so this, oops, let me get my pen ready here. So this function here is the same function that we had on the other slide. So that's the one that we're going to be working with. So it says, how much should Sweet Company charge per can to realize the maximum revenue? And what is the maximum revenue? Okay, so how do we figure this out? Well, remember, let's think about this logically. So this graph, I don't know exactly what it's going to look like, but we know it's going to be a parabola, and it's going to be pointing downwards. And so the maximum revenue is going to be the vertex of that graph. And in this situation, the x, remember, represents the number of 5-cent increases. And the y-axis would represent your revenue. That's how much money you're making. Okay, so in order to first figure out how much they charge per can, well, we want to figure out how many number of 5-cent increases they should do, which is going to be the h value in our vertex. So in order to find h, we do the opposite of b over 2a. So it'll be negative 800 divided by negative, so 2 times negative 50 would be negative 100. So we get 8. So what that 8 represents is that we would have 8 5-cent increases. So when it says how much they charge per can, what we should do is we should take, remember that, let me go back a slide here. So remember this part, get a different color here. So remember this part here represents the price that they would charge after X increases. So we're going to take and we're going to say that there's 8 increases. So we're going to take 0.05 times 8 and add that to 50. So we would have 50 plus 0.05 times 8. So obviously 0.05 is 40 cents, and 40 cents plus 50 cents would be 90 cents. So they should charge 90 cents per can. All right, so now we got to figure out, well, what would be the total revenue? So remember, what we're trying to find is the maximum point there. So we found the h value. So the h is actually 8. So it's going to be 8 increases, 8 5-cent increases. So to find the k value, we're going to plug the 8, not the 90 cents. Okay, we're going to plug the 8 into the original equation. So we're going to take, ignore the noises in the background. That's my girls acting crazy here. So we're going to plug that into the equation to find our k. So that would be the y value. So we would take negative 50 times 8 squared, and then plus 800 times 8 plus 13,000. And when you do that, you end up getting $16,200 would be the total maximum revenue that they would make if they had 8 5-cent increases or sold each can for 90 cents a piece. So that's how we do a maximized profit. Now, here's what you can do. What you can do is you can stop this video now, and you can, because actually this is going to be the end of this video, and you can work on questions numbers 3 and 4 in your homework assignment, because both of those are problems where you're going to be maximizing profit.